Hello everyone, hope you all are doing well. So in this video, we'll discuss the second problem of Leetcode Weekly Contest 326. It's a medium level problem, but the accuracy, as you can see, is on the lower side. Let me just do this. Yeah, accuracy is on the lower side. Okay, so the problem name is distinct prime factors of product of array. So the problem statement says that given an array of positive integers nums, return the number of distinct prime factors in the product of elements of nums. Okay. Note that a number greater than 1 is called prime if it is divisible by 1 in itself, and an integer val1 is a factor of another integer val2 if val2 divided by val1 is an integer. Simple stuff, right? In short, it says that you are given an array, multiply all these numbers. Okay, so suppose for this case you get this number. Now find the prime factors of this number. So what are the prime factors? It is 2, 3, 5 and 7. So the number of distinct prime factors are 4, so you return 4 here. Okay, similarly here, when you multiply all this, you get 1024. So this can be written as 2 raised to power 10, because any number can be written as powers as a product of different powers of prime numbers. So that is why. So there is only one prime number, that is 2, so you get 1, right? So simple implementation based problem. What you will do here is obviously you do not need to multiply the numbers, because what you can do, what are the factors of this? That is 2. What are the factors of this? 2 into 2. About this, 3, 7, 2 into 5, 2 into 3. So actually when you multiply all this, or even if you process them separately, you get the same number. Just see, it is 2, 2, 2, 3, 7, 2, 5, 2, 3. So when you multiply these things, the powers are added, but we do not need to find the sum of those powers. We just need to find the distinct prime numbers. So just see how many distinct numbers are there. 2, 3, 7 and 5. That's it, right? That's written here, because any number that you are getting in the final result is basically a part of any one of these, right? Any one of the numbers present in the array. So that is why the total number of distinct prime factors here is 4. Hence 4 is your answer. So what I mean to say is, process each number separately, and basically you can add the prime factors in a set, and finally you can return the distinct numbers. That's it, right? What are the things to note here is the numbers that I can have is basically so each number can be 10 raised to power 3, and the total number of numbers I can have is 10 raised to power 4. Okay, so I would apply a brute force here, because no need to write the code to optimally find the prime numbers and all, right? So what you can do is, initially just see, I've taken a hash set because I'll be adding the prime numbers here, and finally obviously this set, so the property of a set is containing distinct objects, right? So this will only contain distinct numbers, and finally I return the answer, right? So what I've done, this is my main function. Just see, I've picked up each number and I've called a function process num by passing that number, and this is the core function. What it is doing, okay, you pass a number. I've taken an extra variable as well here, right? You pass a number, and then what you do, so any number will have factors from obviously 1 to n. So 1 is not included here because I need to find the prime factor. So I start from 2 to n. So just see what I've done here, 2 number. Now what I do, if my current number is dividing n and num are same right now. So what do you do? While I is dividing n, you keep on dividing it. What do I mean by this? Suppose you have 8. So is 8 mod 2 equals 0? That means is 8 dividing 2 is 2 dividing 8? Yes. So what you do? You start a while loop, because irrespective of how many times it is being divided, you reduce this number, right? So you divide this, so it becomes 4. You again divide it by 2, it becomes 2. Then you divide it by 2, it becomes 1. You keep on doing this while 2 is able to multiply your this number 8, 4 or 2, right? You can see n. So that is why I've taken two variables. Nums is something that you have passed, and n is the new number that you are getting every time, because this number is being reduced, right? Because you are dividing it by its prime factors. So you do it, then you add I, because you are dividing the current number by I into your set, right? And finally you just see if n equals to 1, because this number is being reduced. Just see, while n mod I equals 0, n divided by equals to I. So if n equals 1, so you just return the function, because I found all the prime factors. And finally obviously the set will contain the distinct prime factors, so you return it, and that will be your answer, right? So yeah, that's it for this problem. I hope you learned something new from this video. Do support it by giving up a thumbs up. Do subscribe to the channel as well. In case of any queries, please do let me know in the comment section. I'll revert on each one of them. Thank you. Take care. Bye bye.